All right, I will be talking about interference and other phenomenon as it relates to waves. So wave interference is something that happens when two waves meet and interact while traveling along the same medium. So for example, two sound waves, either their frequencies or what have you, while they're meeting in the medium, can interfere and either be constructive or destructive. So here's what I mean by constructive is if you can see the waves, so the red wave and the blue wave here are two different waves uh, traveling along the same medium. And since their crest kind of meets kind of at the same time here, the observer almost sees like this green wave, like one big wave rather than two smaller waves. So that would be constructive interference. So the amplitude seems to get larger. This would be an example of destructive interference. So again, the red wave and the blue wave are two separate waves, but notice how the crest and the trough are kind of meeting at the same point in time. And the observer will see, in this case, almost like there's no wave uh, or a perceivable decrease in amplitude of the wave. Okay, another phenomenon that can happen with waves is the Doppler effect. And this can happen with mechanical waves and electromagnetic waves. So if you can imagine, here is an example of a police siren, and you can see visual sound waves radiating out from the police siren. Now, the speed of sound, I don't remember it exactly. It's somewhere around 700 miles per hour. Say the police car is moving at 70 miles per hour. That's about 10% of the speed of sound. So that's significant. So as the sound is moving out at one speed and the police car is moving in the same direction uh, at, at speed, it's going to cause the sound waves to kind of bunch up at one side, and the way it's moving away, it's going to spread out on the other side, causing it to sound lower when an object is moving away from you and sound higher pitched when the object is coming towards you. As I said, this can also happen with electromagnetic waves as well. When something's moving very far away from you or very fast at you, talking about very fast, something can happen where it's called blue shifting and red shifting. Now, an extreme example of the Doppler effect is shock waves or sonic booms. So the shock waves are when the sound waves start to pile up in front of the object. So you'll see this with supersonic aircraft. And then once they travel faster than the speed of sound is still going to radiate out in all directions from the source of the sound. But since the object is moving faster than the speed of sound, it's going to cause the shock wave to just kind of build up along uh, along these kind of angles here. And that's what sonic booms are. Is all the sound waves from a bunch of different points of time will hit at the same time. So that's what I'm talking about here. So these high pressure regions will build up over time. Okay, standing waves is something that happens when two or more waves of identical frequencies interfere and produce a wave that seems to be standing still. So, energy, if you can imagine energy traveling from like left to right here along the wave, but it looks like the nodes of the wave are just kind of moving up and down. So now, the frequency associated with a standing wave pattern, these frequencies are also associated with patterns referred to as harmonics. So the fundamental frequency would be the lowest frequency within the standing wave pattern. But if you start to have duplicates or triplicates, this would be multiples of this fundamental. So if this was 10 hertz, this would probably be 20 hertz. This would be 30 hertz. And these would be the harmonics of the fundamental frequency.